Welcome to the 5th video in the series on how to build a 3D game using Three.js and Typescript. In this video, we will learn how to create elements that block the player movement. We will cover two concepts: creating a new game entity, in this case a wall object, and how to program the logic to make the tank react to the existence of this wall. To make things easier, we will first make some very small changes on the game scene. The first one is to save the map size as a variable. We will use this value later. The second change is exposing the camera instance. This will allow us to change its position. We will make the camera focus on the player tank. The final change is to expose the list of game objects. The player tank will need to check the current objects to determine if one is blocking its path. We will now make the camera follow the player movement. The change is very easy. We will just update the camera position after the tank has moved. Now that we have the camera ready, we can focus on how blocking objects work. The concept of how entities interact and their reactions is usually referred to as collision detection. There are many ways of resolving when two objects collide, but for this series we will keep it very simple. Game entities will have a new property which is going to be a collider. This is going to be an object we can use to know if a collision happens. For this tutorial we will consider three cases: a sphere, a box, or nothing. To see how collision works, we will create some walls in the game. Let's prepare the texture first. The wall class will extend from GameEntity, which allows us to have a lot of code ready to be used. Like with any class extending from GameEntity, we have to provide the initial position. As before, we will use the load method to create the geometry and apply the material to the object. Walls are very simple. They use a box geometry and a mesh standard material. For the map, we will use the texture we just loaded on the resource manager. With the geometry and material, we are ready to create the mesh. Remember, anytime we create a new mesh, we have to set its position. We are ready to add some walls to the game scene. For this, we will create a method to help us place the walls around the map. To make the code a bit easier to read, I will create a helper variable. This represents the edge of the map in terms of the array position. This is just for the algorithm, and you can change it however you think it's easier for you. My goal is to first create a wall on each edge of the map and then use a for loop to fill in the gaps. At this point, I have created the first 4 walls. Let's call the function and see how it looks. Using a simple for loop, we can fill in the missing spots between the edges of the map. Now that we have the walls around the map, it's time to create the collider to make them solid. The type of the collider we will choose will depend on the shape of the object. In the case of the wall, we will use a box collider, since it's basically the same shape. Although the walls have their collider, we can go through them. This is because the tank does not have a collider or the logic to react to solid objects. We will now create a collider for the tank. In this case, we will use a sphere. The reason I'm choosing a sphere is because it's a bit more flexible when rotating the tank. Creating a sphere that fits all the vertices of the mesh is tricky because we need to create a box first. Reducing the radius a bit will make the collisions a bit more flexible. The tank now has a collider. It's a sphere that contains the mesh, but we're still able to go through walls. The final step is to check for solid objects before we move the tank. We will clone the tank collider, place it where the tank should move, and check for possible solid objects. If a collision is found, we cancel the movement. We need to get a list of objects that may be causing a collision. We filter all the objects that are not the current tank and have a collider. If they do have a collider, check if a collision happened. If the resulting array has results, then a collision happened and we should not be moving the tank. If there was no collision, we need to update the position of the collider. We can finally see the tank reacting to solid objects on the scene. In this lesson, we learned how to implement a basic collision detection algorithm by using simple shapes containing the game entities. This type of collision is very fast and not very taxing. I believe it can be used for simple games. In the next class, we will see how to implement a basic shooting mechanism. And as always, thank you for watching and I hope to see you in the next video.